Good day everyone. Today we are going to learn Chapter 7. Permutations and Combinations. Permutations Part 4, R, Identical Objects. Learning outcome for today is to find the number of permutations of n objects, comprising of R sub 1 identical objects of type 1, R sub 2 identical objects of type 2, until R sub k identical objects of type k, where R sub 2 plus R sub 2 until plus R sub k equals to n permutations, where some objects are identical. Consider the number of permutations of the letters B, A1, N1, A2, and 2, and A3. Permutations of the 6 letters is 6 factorial, whereas the permutation of A1, A2 and A3 is 3 factorial, and the permutation of N1 and N2 is 2 factorial, which we have already counted in 6 factorial. The permutation of identical objects will always be 1, because however we arrange them, it will end up with the same arrangement. The permutation of 3 identical A is 1. Similarly, the permutation of 2 identical N is also 1. So, the permutations of the letters B, A, N, A, N, A, with 3 identical A, and 2 identical N, will be 6 factorial. Divide by 3 factorial times 2 factorial. 6 factorial, when we consider all the 6 letters are different, and we divide 6 factorial by 3 factorial times 2 factorial to discount the calculation of permutations of the 3 identical A, and 2 identical N. So, the number of permutations of n objects, comprising of R1 identical objects, R2 identical objects, until Rk identical objects is n factorial. Divide by R1 factorial times R2 factorial times until Rk factorial. Example 16. How many different permutations can be made using the letters of the words A, books, B, lotto, C, mathematics? Solution for A. The number of letters in the word books is 5. So, n is equals to 5. There are 2 identical O. So the permutations of 5 letters, with 2 identical O, are 5 factorial. Divide by 2 factorial, is equals to 60. Solution for B. The number of letters in the word lotto is also 5. So, n is equals to 5. There are 2 identical O, and 2 identical T. So the permutations of 5 letters, with 2 identical O, and 2 identical T, are 5 factorial. Divide by 2 factorial, times 2 factorial, is equals to 30. Solution for C. The number of letters in the word mathematics is 11. So, n is equals to 11. There are 2 identical M, 2 identical A, and 2 identical T. So the permutations of 11 letters, with 3 sets of 2 identical letters, are 11 factorial. Divide by 2 factorial, times 2 factorial, times 2 factorial, is equals to 4,989,600. Example 17. There are 2 copies of each 3 different books to be arranged on a shelf. In how many distinguishable ways can this be done? Solution for example 17. The number of books is 6. So, n is equals to 6. There are 2 same identical copies for each 3 different books. So the permutations of 6 books, with 2 copies of 3 different books, are 6 factorial. Divide by 2 factorial, times 2 factorial, times 2 factorial, is equals to 90. Proceed to example 18. Ida bought 3 original flavored, 2 green tea flavored, and 4 durian flavored choco jars to be given to her nephews and nieces. How many ways can she distribute 1 choco jar to each child? Solution for example 18. The number of choco jar is 9. So, n is equals to 9. There are 3 original flavor, 2 green tea flavor, and 4 durian flavor. So, the permutations of 9 choco jars with 3 different flavors will be 9 factorial. Divide by 3 factorial, times 2 factorial, times 4 factorial is equal to 1260. Example 19. A hockey team has a record of 10 wins, 5 losses and 3 ties in 18 games. How many different ways could this records have occurred? Solution: for example 19. The number of games is 18. So, n is equals to 18. The records are 10 wins, 5 losses, and 3 ties. So the number of permutations of 18 games, with 3 different records stated, is 18 factorial, divide by 10 factorial, times 5 factorial, times 3 factorial, is equals to 2,450,448. Our last example is example 20. How many possible permutations of the letters of the word A, D, D, I, N, G can we get if the two D's, A, are together, B, are separated? Solution: for example 20. Number of letters is 6. So n is equals 6. And we have two identical D. For case A, where the two D's are together, we arrange the two D's first. So, we will get 2 factorial divide by 2 factorial. Next, we arrange the remaining 4 letters, along with the two D's, that has become one object, and permutate them together. We will get 5 factorial. The number of permutations we will get is 2 factorial divide by 2 factorial, times 5 factorial, is equal to 120. For case B, the permutations if the two D's are separated is calculated by permutations when there is no restriction, minus permutations when the two D's are together. So, the permutations that we get is 6 factorial divide by 2 factorial for no restriction, minus 120, that is the permutation when the D's are together, equals to 240. That is all for today. Thank you for watching. Please don't forget to do the exercises in this slide.